So hello guys, today we are going to solve a Leetcode question, that is 2 sum 2. 2 sum 2, you remember we had done the 2 sum 1, 2 sum 1, no? We had you remember we did this question, right? 2 sum, that is the simple 2 sum. It's just a variation of it, where it is given that the input array is sorted, where you are given the sorted array in this case. Okay, so let us first try to see what the question is trying to say. What the question is trying to say. Why is there a variation of it? Why is there a variation? There must be some change to the question, right? First change we got to know is input array is sorted. First change we got to know is input array is sorted. Okay, I'll try to I'll try to tell you, but first we'll try to read the problem statement. What the problem statement says. Okay, so, given a one indexed array of integers nums that is already sorted in non-decreasing order, you are given a one index integer of array. Yeah, that is 1D array. That is a normal array you are given, and you are said that the input array is sorted. Find two numbers. You have to find two numbers such that they add up to a specific target number. You have to from that whole array you have to find those two numbers that sum up to target. Suppose this is my number 1 and number 2, that should be equal to target, equal to true. Okay, this should come as true. So let these two numbers be. Now reading the question again, going forward, let these two numbers be numbers index of 1 and numbers index of 2. Here my array is given as numbers by the name numbers, array or vector. Okay, where I is less than equal to index 1, less than index 2, not equal to numbers of length. That means that both of the indexes you choose shall be between 0 and numbers dot size minus 1. Numbers dot length means the last element, that should be equal to the last elements. Remember, length function gives me the pointer to the last element, whereas numbers dot size will give me a pointer to the succeeding element of the last element, that is plus 1, the last element. Okay, so I have to choose these two indexes. Okay, return the indexes of the two integers, index 1 and index 2, added by 1 as an integer array, index 1 plus index 2 of length 2. What does it mean? Return the indexes of two numbers, index 1 and index 2, added by 1 as an integer array. As an integer array. Okay. Integer array, index 1 and index 2 of length 2. Basically, it is a zero index array and you have to make it, okay, it is a zero index array, but you have to make it a one index array. So what you will do is you will just add plus 1 to the indexes that you will return. It is as simple as that. Don't just what we are given till now, numbers dot, you have to find two numbers in between the size of the array, and you have to convert that, you have to add 1 to both the indexes that you find. Okay, the tests are generated such that there is exactly one solution. It is given that in the test cases are ordered such that there is exactly one solution. There is exactly one solution to this question. Okay, your solution must use only extra space, constant extra space. It is a constraint, right? You can use only O of one space. That is why it is different. That is why it is a different then the two sum problem that we discussed. If you remember, if I try to take this test case 2, 7, 11, 15, 2, 7, 11, 15, and my target is 9. Target is 9. So what I did in that question was, I made a map. And while I'm traversing the array, I'm storing one occurrence of these elements. And what I'm doing along with it is I'm just simply subtracting it. I'm simply subtracting the element. I'm simply subtracting the element from my target to get this value. And if this value is present in my map, then I was simply returning the indexes of these elements. I was simply returning the indexes of these elements. Okay, if you want to know more about this solution, you can just simply visit my video, visit my two-sum video. Okay, I'll just simply attach the link in the description. Okay, now coming to the solution, coming to the this question solution. Two-sum 2 using constant space. Okay, I got it. Constant space. Okay, constant space numbers. So what I can observe is now I cannot use any map. Map is restricted, because if I use any map, then it will occupy O of n space. That is not allowed. Okay, if I use the O of n square approach, that is trying all the combinations, all the possible combinations, that is combining 2 with 7, then combining 2 with 11, combining 2 with 15, and then combining 7 with 11, combining 7 with 15, combining 7 with 2, trying all these combinations. You can try all the combinations, but if you carefully observe, if I tell you the constraint is 3 into 10 raised to power 4. So if I try to implement a solution of 10 raised to power 4, 3 into 10 raised to power suppose, and square it, so it will result in a time complexity of 9 into 10 raised to power 8. That will take 900 seconds to execute. So this cannot be my solution. Okay. So what can be my solution? How can I get to the solution? How can I get to that solution? Okay. I am given a simple hint in my title only. Input array is sorted. Why it is given that input array is sorted? Sorted. What is the meaning of sorted here? Sorted means in non-decreasing order means 1, 2, 3, 4. 1, 2, 3, 4. So it is given in increasing order. But why I am given like this? Why I am given about the word sorted? Okay. If I try to take this test case, okay, and if I am said to give a target of 3, okay, give a target of 3, okay. So suppose my target is 3. Okay. So if all of my numbers are positive, let us check if my numbers can be negative. Yes, my numbers can be negative also. My numbers can be negative also. Okay. So if I choose an element, as a starting element, like if I choose this, I have to make a target 3. Okay. And if I choose this as my first element, okay. And if I choose this as my second element, no. See, if I choose this as my first element, and if I choose this as my second element, first element and then second element, okay, so it would give me a basically like I can get a number out of it. Okay, I can get a number out of it. Like if I try to sum the first and the last one, suppose this we name it as last. Okay, first plus last one, what does it become equal to? 1 plus 4 equal to 5. Okay, 1 plus 4 equal to 5. Okay, I'll do it on the next page. Okay, 1 2 3 4, my target is 3. Okay, if I place my pointer to this position and to this position, okay, this is my first pointer, this is my last pointer. If I try to sum both of these elements, then what is my sum? 1 plus 4 equal to 5. 1 plus 4 equal to 5. Okay, yes, okay. Now, is my 5 greater than 3? Is my 5 greater than 3? Yes, my 5 is greater than 3. Obviously, my 5 is greater than 3. Okay, so what I can do to reduce this number? What I can do to reduce this number? Okay, if I try to make this pointer, move forward, if I try to make this pointer move forward to this element, then will my value of 5 decrease? Will my value of 5 decrease? I have replaced I have replaced my 1 with 2. Will my value decrease? No, my value is gonna increase. So how can I decrease my value? Suppose my first is still here. How can I decrease my value? Yes, I can lower down the index from fourth element from 4 to 3. Suppose if I replace it by 3, okay, if I replace it by 3, so what my target value, what my sum becomes? 1 plus 3, that is equal to 4. 4 is still greater than 3. 4 is still greater than 3, but it is less than 5. Okay, now suppose if I still, now 4 is still greater than 3, so what I'll try to do is I'll still try to reduce my sum. And how can I reduce my sum? I can simply reduce my sum by pointing the last pointer's value, to the previous element. Now to the next previous element, I'll decrease my last pointer. My last pointer would be here. Okay, if I decrease my last pointer, would be here. So will is it gonna increase the sum or decrease the sum? Suppose my sum was 1 plus 3 equal to 4. I am erasing this 3 and I am putting 2. Will it gonna be resulting in a sum that is 3? Is 3 greater than 4? No. 3 is less than 4? Yes. 3 is less than 4. So I have successfully reduced my values. And eventually I have seen that my sum has become equal to the target. Okay. So I can infer from here is, if I see this 1 3 2 7 and target is equal to 5. Okay, what I can infer from this is, if I take my first element to be this, and if I take my last element to be this, I'm just supposing these elements to be true. Okay, and if I try to just sum them, I'm getting a value that is greater than my target. So what I can do to achieve the target sum, I'll try to reduce my value. So what I can do to reduce my value is going to increase the front pointer, decrease my value? No, because as it is a sorted array. Sorry, so this is gonna be 2 and 3. As it is gonna be a sorted array, so increasing the first pointer, replacing it by 2 is not gonna decrease my value. It is gonna be resulting in a sum 9, that is still greater than 5. I'm not going towards 5. So if my 5 is here and my 9 is here and my 8 is here, sorry, so I'll try to decrease the values. I'll try to go towards the left side. Okay, so I'll simply decrease this pointer's value. This is gonna be L. So what I'll do is, now I'll first sum this. 1 plus 3 is equal to 5. 1 plus 3 is equal to 4. Now what is 4? 4 is less than 5. 4 is less than 5. So what I'll try to do is, I'll try to increase my sum. I'll try to increase my sum. So how can I increase my sum? I can increase my sum by simply adding, like simply incrementing the first pointer's value. My first pointer was here, first pointer was pointing here. I am simply changing its value and increasing it by 1. Okay, now my first pointing is pointing towards the 2 second element, and last point is pointing towards the towards 3, so it becomes 5. It becomes 5, and 5 is equal to the target. 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 So this becomes my answer. Will I try again? Will I try for any other combination again? No, no, no. Okay, why no? Because you are given that there exists only one answer. And suppose if there doesn't exist any answer, suppose we were on this case, this was my last pointer and this is my first pointer. Will I go again? Will if my 4 is greater than 5, if my 4 is less than 5, my target value was 5. If my 4 is less than 5, what I'll try to do is, I'll increment my first value. So my first would come here. My first and last are on the equal element now. My first and last are on equal element, on the same element. Will I try this combination? Will I try 2 plus 2? Will I try to add this 2 with this 2 only? Will I try to add this 2 with this 2 only? No. It is strictly said in the question that you may not use the same element twice. You cannot use the same element twice. So what is gonna be the ending condition for this? As my first pointer, I'll run the loop till my first pointer stays less than the last pointer. Okay, so this will be my ending condition. So now I'll just simply see why is it working. Okay, I'm just supposing a value. Suppose you have a number guessing game. Your choice number is 50. Your chosen number is 50. How can you determine it is 50? If someone is asking you that what is the number that I have guessed, that is in my mind. You guess a number that is in my mind. Okay. So if I have 50 in my mind, I tell you that I have a number in the range 1 to 100. It can be any number. Suppose I have chosen 50 in my mind. Okay, 50 in my mind. So what you will try to guess? You will try to guess 30. I'll say no, it is higher than the value that you are saying. Okay, you will guess 70. I'll say that it is lower than the value that you are saying. You will get 60. I'll say that it is still lower than the value you are saying. You will say 55. I'll say it is still lesser than the value that you are saying. You will say 50. When you will say 50, I'll tell you that yes, 50 is my correct answer. 50 is my correct answer. So this is the approach that I'm following. I'm just simply randomly putting the values, first and last pointers value on the first and the last element. So I could traverse the whole array. And I can try all the combinations. Okay, that could simply give me the result. Okay, so that is what I am doing. Suppose if I try one more case of negative elements. Okay, of negative elements. -4. Okay, of negative elements, increasing order, right? So -4, -3, -2, -1. I have to get a target of 5, -5. What I'll place? I'll place my first pointer here, my last pointer here. I'll sum these elements. What I'll get is -5. Okay, no, I shouldn't get -5. I'll say 0. It's 0. Okay, it's 0. It is 0. So what I'll get is -4. Is -4 less than -5? Is -4 less than -5? No, it is greater than -5. It is greater than -5. So I'll increase my front pointer value. My front pointer is point here. Okay, and my last pointer is here on 0th element. So now my first pointer is pointing here, and my last pointer is pointing here. I'll try to sum again. Minus 3 plus 0 is equal to minus 3, and my target value was minus 5. My target value was minus 5. Okay, what I'll say is my minus 3 greater than minus 5? Is my minus 3 greater than minus 5? Yes. Yes. Okay, so I'll try to decrease my value. So what I'll do is I'll just simply add it. With this. I'll simply reduce my low pointer's value, last pointer's value. So my last pointer would come. My last pointer would come here. Now my last front pointer is pointing towards minus 3, minus 2, 0, and minus 4. My last first pointer is here, and my last pointer is here. If I try to sum them, what I get is minus 5. Yes, that is exactly equal to the element, that is exactly equal to the target that I was trying to find. Okay, so this is basically the two pointer approach that I'm following. I'm just randomly putting it on the first and the last element. If the target is greater and summing them, if the sum is less than target, I'm just simply increasing my friend's pointer value. If the sum is equal to target, I'm returning those elements, and if my sum is greater than target, I am reducing my end pointers value. Okay, this is what I am doing. If I try to write the code for this, so first pointer would be my starting pointer, ending pointer would be at numbers.size minus 1, and I'll go till my start pointer is less than my end pointer. If my I'll try to calculate a sum that is of numbers start plus numbers end. Okay, if my sum equal to my target, if my sum is equal to my target, what I'll do is I'll simply return the start plus one element, because I'm said that you are given a zero indexed element and given a zero indexed array, and you have to return a one indexed array. Okay, my sum is equal to target, I'll simply return it. If my sum is less than target, I'll still have to increase my value. So for increasing my value, what I'll do is I'll increment my first pointer, I'll increase my start pointer. Okay, and if my sum is greater than target, that is lying somewhere there, I'll simply decrement my last pointer's value. My last pointer is end here, so I'll decrement the value. And what if the loop fails? What if there is no condition? What if there are no elements that sum up to the target? Okay, so I'll just simply return minus 1 and minus 1. Okay, I try to run it. Okay, accepted. Okay, so this was the solution of the question. If I try to give the summary, what I'm doing, I'll just simply randomly choosing the elements, first and the last elements, as my answer. If it is not the answer, if it is greater than the answer, if I'll try to reduce the elements, I'll try to reduce the sum by reducing the last pointer's value by 1. And if it is greater, like if the target sum is greater than my sum that I have calculated just now, then I'll increment my start pointer's value. Okay, and if my sum is greater than the target, equal to target, that is equal to target, sum is equal to target, then I'll just simply return. Suppose I have said you to guess a number, and I have in my mind 50, and you have guessed 50 only. So in the first chance only, you are able to guess that number, right? So if that happens, I'll simply return the indexes. So if I talk about the time complexity, I'm just simply running the loop once, as my start pointer is at starting and my end pointer is at the last. My starting pointer can go till here and my ending pointer is coming till here. Okay, and if I try to sum them, I'll just simply get it as the length of the array. So my time complexity becomes O of n. And what is my space complexity? As I'm not using any extra space, I'm just returning an element. The space complexity becomes O of 1. Okay. So this was the solution of the question 2 sum 2 input arrays sorted. I hope you guys enjoyed the video. If you have any doubts regarding this question, you can just ping down in the comments. And if you like the solution, do share, subscribe. Okay, thank you. Bye bye.